Hi, I'm Mrs. S from Steps to Success Maths. In this video, we're working through GCSE exam questions on Pythagoras. We're going to start with the easiest questions and build up to the hardest ones. Pause the video, have a go, and then we'll go through each question step by step. Let's look at the first question. ABC is a right-angled triangle. AC is 9 centimetres and BC is 11 centimetres. Calculate the length AB. Give your answer to one decimal place. So remember, Pythagoras' theorem only works in a right-angled triangle. It says that the longest side is equal to the sum of the other two sides when you square them. So you might know it as a squared plus b squared equals c squared. Remember, always start with the longest side. So here we want to find AB, which is the longest side. It's the one opposite the right angle, called the hypotenuse. So AB squared is equal to the other side squared, add it together. So 9 squared plus 11 squared. Now make sure you write that line down so you don't lose any marks. Then you can work it out. So you can use a calculator. 9 squared plus 11 squared is 202. Now, don't forget the next step. You know what AB squared is and you just want the length on its own. So you need to square root. AB is equal to the square root of 202, which is equal to 14.216 ... Make sure you write down quite a few numbers from the display on your calculator. That way, if you forget to round, you're not going to lose out any marks. And then we need to round to one decimal place. So that's 14.2. ABC is a right-angled triangle. AC is 20 centimetres, BC is 8 centimetres. Calculate the length AB. Give your answer to one decimal place. So again, it's a right-angled triangle. We know we're going to use Pythagoras. So the side we want, AB, is a shorter side. So AB squared plus the other short side, which is 8 squared, must be equal to 20 squared. A little bit of rearrangement. We've got AB squared is equal to 20 squared, take away 8 squared. Make sure you've written this line down. And then if we work that out, we've got 336. So AB is the square root of 336. Pop that on your calculator and remember to write down lots of the digits. So that's 18.3303 ... And then if we round that to one decimal place, we've got 18.3. ABC is a right-angled triangle. AB is 13.85 centimetres, BC is 7.25 centimetres. Calculate the length AC. Give your answer to one decimal place. So we're trying to find the longest side. AC squared is equal to 13.85 squared plus 7.25 squared. This one isn't really any harder than the others. It's just got decimals in it. We do it exactly the same way. Let's pop it on our calculator and work that out. So that's 244.385. And then we need to square root our answer to get AC. So that's 15.6328. And then if we round to one decimal place, we've got 15.6. ABC is a right-angled triangle. Work out the perimeter of the triangle. So this is trickier because it doesn't ask for a length, but in order to work out the perimeter, which we know is the distance all the way around the outside, we're going to need this missing length. Now remember, it's a right-angled triangle and you already know two lengths and you want to work out a third. That's how you can tell it's Pythagoras. So AB is the side opposite the right angle, so the longest side. AB squared is equal to 5 squared plus 12 squared. And then if we work out 5 squared plus 12 squared, we get 169. And so AB is the square root of 169, which is exactly 13. And now don't forget to answer the question. We want the perimeter. So that's going to be 5 plus 12 plus 13, which is 30 centimetres. Calculate the area of the right-angled triangle. Give your answer to 3 significant figures. Calculate the area. So how do you work out the area of a triangle? It's base times height divided by 2. The base is this length along the bottom. Let's call it x. The height is where it makes the right angle with the base, so 12. So we need to work out the length that we've called x. We've got 2 other sides, so we know it's Pythagoras. So we want to work out x. So x squared, x is a short side, plus the other short side, 12 squared, is equal to 18 squared. 18 is the longest side. A bit of rearrangement, we've got x squared is equal to 18 squared take away 12 squared. And if we work that out using a calculator, we're going to get 180. So x is equal to the square root of 180, which is 13.4164 ... So leave that answer on your calculator. Then you can use it to work out the area. So the area is 13.4164 ... times 12 divided by 2. And if we do all that on our calculator, we get 80.498. And if we round that to 3 significant figures, so that's 3 numbers, we've got 80 point, remember the 9 rounds up to the 4, so that's 5, 80.5. A 5-metre ladder is placed against a vertical wall. The base of the ladder is 1.8 metres from the base of the wall. Find the height the ladder reaches up the wall. So this is a Pythagoras question, but written in an unusual way. And the exam boards do like to ask their ladder questions, so don't get put off. So let's draw a little triangle and write the information on it. So we've got 1.8 and 5 metres and a right angle, and we're looking for the height. Let's call it h. So which is the longest side? That's the actual ladder, isn't it? So that's this side here, 5 metres. So we've got h squared plus 1.8 squared is equal to 5 squared. So h squared is equal to 5 squared, take away 1.8 squared. So if we put that on our calculator, we're going to get 21.76, and then we need to square root our answer. So 21.76 square rooted is 4.6647. Write down all the numbers on the calculator and then round. Now round it to what they call an appropriate degree of accuracy, which basically means don't go any more detailed than the question. So in the question, the most detailed is 1.8 metres, 1 decimal place. So round your answer to 1 decimal place, 4.7. Calculate the length CD. Give your answer to 1 decimal place. So when you look at this shape, you've got to realise it's made up of 2 right-angled triangles. The first one is ABD. And so if I wanted to find the length B to D, I've got the longest side is 21 and the other short side is 15. So I'm going to use Pythagoras. So BD squared plus 15 squared is equal to 21. So BD squared is equal to 21 squared, take away 15 squared. And that's 216. And then to find BD, we would square root 216, which is 14.696 ... Okay, and so now I've got the triangle BCD, and I know what this side is. It's 14.696 ... or I could call it the square root of 216. whichever you find easiest. Just remember, if you're going to use the decimal, use plenty of digits so you don't get a rounding error when you work it out. So this time I want to find the length CD, which is the longest side. CD squared is equal to 9 squared plus what we worked out, squared, BD squared. And I know BD squared is 216. So CD is equal to 216 plus 9 squared, which is 297. And then if I square root my answer, I'm going to get 17.2336. I'm going to round that to one decimal place, 17.2. ABC is an isosceles triangle. Calculate the perpendicular height of the triangle. Give your answer to one decimal place. So the word perpendicular means at right angles. So we can put a right angle in this triangle. And I'm actually going to pick out that one triangle. I'm going to highlight it here. Okay, so this side length will be half of the base. So that's going to be 6. I know this side is 11.5. And I've got a right angle here and I want to find the height. Let's call it H. So which is the longest side? That's 11.5. So I've got H squared plus 6 squared must be equal to 11.5 squared. So H squared is 11.5 squared take away 6 squared. Using a calculator, that's 96.25. And to find H, I'm going to square root 96.25, which is 9.81 ... and round it to one decimal place. So 9.8. Why don't you try my free worksheet with work solutions so that you can keep practicing this skill? I'm creating videos for the whole of the GCSE Maths course, and to make sure you don't miss any, be sure to subscribe.